On today's episode, I'm going to go over the American Journal of Civil Defense, Volume 1, Number 4, from November to December 1968. Blast-resistant cable routes is one of the articles on here. And this magazine also is called Survive. And I'm going to scroll through. There's a couple of sections that I've marked out I didn't want to go over, and then I'll just start reading from there and go through those parts. Out of the cobwebs. Real leadership is required from the president. If the Congress is reluctant, which it is, if the public is apathetic, which it is, then it will take a clear call from the president, a speech as forceful as either his Atoms for Peace or his Middle East speeches to arouse the American public to the mortal danger civil defense authorities believe we face. Occasional paragraphs in the State of the Union message or in the presidential budget document are not enough. A major and continuing effort is demanded. If the American people are informed, they will support the measures necessary to improve our civil defense structure. Ex-civil defense chief criticizes civil defense policy. In delivering the keynote address at the United States Civil Defense Council's 17th Annual Conference in Milwaukee, on October 28th, Val Peterson, Civil Defense Administrator under President Eisenhower, asserted that Washington officials were withholding vital civil defense information. As an example, he claimed that the public had not been adequately informed on the need for blast shelter in urban areas. In Peterson's words, the policy of secrecy means we are writing off the people in metropolitan areas. What disturbs me, he added, is that residents may be led to believe they are getting some protection. Peterson further stated that civil defense had lost prestige and public respect when the Civil Defense Administrator was downgraded from a presidential appointee who attended Cabinet and Security Council meetings. In his talk, Peterson paid tribute to Survive and to the book Who Speaks for Civil Defense as serious efforts to bring the facts of realistic civil defense to light. Survive is published bi-monthly by the Association for Community-Wide Protection from Nuclear Attack. Survive presents authentic information related to civil defense, to the survival of free government, the United States, and its people in the nuclear age. Its aim is public education in this field and service as a forum. The mole psychology doesn't appeal to us. Neither did the foxhole psychology of World War II and Korea, nor the trench psychology of World War I. But we dug our foxholes, and our fathers and grandfathers dug their trenches. A shelter policy is not a mole policy. It is a timeless policy of humanity protecting itself from a hostile environment. The psychology that gave us warm clothes, the Sabin vaccine, and parachutes. Thomas Martin and Donald Latham in Strategy for Survival, University of Arizona, Tucson, 1963. AT&T goes underground across I think it's supposed to be across the United States. There's a picture here that shows a typical communications control room under construction. Once construction is completed, earth is backfilled around the walls of the structure of the building and over its top. In this case, a gently sloping hill will cover the structure and help to give it the required blast protection. Communication capabilities in disaster situations require the survival and continued functioning of communication equipment and operating personnel. Realistic protection and systems flexibility assure the United States have continued landline communication under the emergency conditions of both natural and nuclear disaster. Some of the advanced techniques developed by modern American communication pioneers are outlined in this staff study. 4 years ago, on December 2nd, 1964, the American Telephone and Telegraph Company put its first blast-protected coax cable into service. It spans the country from New York to Los Angeles. It gives wide berth to all cities and to all points that could be considered likely nuclear targets. Along its entire length, it is buried at a depth of 4 feet or more. The 11 control centers which service it are also underground. The entire system is blast protected. It is built to withstand shock waves of over 100 pounds per square inch, which means it will survive anything short of a direct hit by a nuclear weapon. It will also be able to function independent of outside help from a period of over 3 weeks. It is designed to provide added protection against natural disasters such as floods, hurricanes, and tornadoes, while at the same time providing protection against the new threat of our times, nuclear attack. This was a beginning. Since then, our cables have been planned, and the nation is now being crisscrossed with these revolutionary systems. As this work progresses, new improvements are being made to increase capacities and effectiveness. A Boston to San Francisco cable, for instance, will raise the initial limit of 9,300 two-way conversations to 32,400 over major portions of the route. This project is due for completion in 1972. A similar cable between Boston and Miami is now in operation south of Washington, and the section between Boston and Washington is under construction. Another cable being built from Newark to St. Louis and Chicago will also boast a capacity of 32,400 two-way conversations. It will be finished in 1972. Plans for a new coaxial cable route for the Southwest were announced in September by AT&T's Long Lines Department. This new route will extend from St. Louis to Los Angeles, and it will handle 90,000 two-way calls at one time, like its predecessors, it will also carry several forms of landline communication, including telegraph, teletypewriter, and television. Target date for completion is cautiously set in the middle 70s. More projects are in the thinking stage. Each one requires close coordination with Bell Systems and independent telephone companies and purchases of property and right-of-way. Each brings an army. More projects are in the thinking stage. Each one requires close coordination with Bell Systems and independent telephone companies and purchases of property and right-of-way. Each brings an army of executive, technicians, and workers into play. Each brings its own problems and its own improvements. Each brings emergency communications as well as everyday service to a new plateau of effectiveness. Total cost of these projects, with complete equipment, now come to nearly $1 billion. The additional cost of obtaining maximum protection for cable systems is small because of the inherent strength of the cable. Thus, increased communication reliability is provided economically. All the underground coaxial projects have certain design characteristics in common. The control centers are responsible for maintenance of the cables at specified distances in each cable direction from the center. Above each underground control center is a small entrance that has personnel are admitted to stairwell inside. The checkpoint here is provided with telephone connections to control personnel as well as the closed-circuit television. The stairwell ends at a 3,200-pound lead-lined motor-operated concrete door. The door slowly opens with a loud bell, while a loud bell rings and a red light burns. These signals give notice that entrance or exit mechanisms are in operation. Inside is a small access vault where those entering the installation must wait while the first door closes. Once closed, a second 3,200-pound door leading directly into the communications center slowly opens and slowly closes, again accompanied by red light and clanging bell. Outer walls of the control center are 18 to 24 inches thick. Inside, all vulnerable equipment and individually shock mounted. Flexible piping is used where utilities penetrate walls. Stocked emergency living quarters are available for operating personnel. Emergency generators stand ready to supply power. Emergency fuel is stored in buried tanks. Ventilation intakes would automatically close upon detection of nuclear blast. After the blast, filters would cut in. Special blast-protected radiological monitoring equipment positioned above the control center would report radiation levels to those inside. These hardened construction techniques give the control center effective target area blast protection in non-target locations. Protection from fallout radiation is above 100 times greater than that specified by the Office of Civil Defense for government emergency operating centers. Why? Why has the American Telephone and Telegraph Company in the past 10 years devoted a major portion of its efforts toward perfecting a system of subterranean communications capable of withstanding both natural and nuclear disaster? A Long Lines Department engineering spokesperson answered the question in this way. It has always been a Bell Systems practice to provide economically prudent means of protecting telephone plant against hazards that might interrupt communication services. Throughout the years, the need for continuous communications service has become increasingly critical. Technological innovations have been made to provide every possible measure of protection against natural catastrophes such as floods and hurricanes, and man-made failures such as shock waves from nuclear blaster construction work. New facilities are planned using these innovations to provide maximum service continuity, but these are only additions to an existing network that strongly promotes survivability through use of route diversity, alternate route switching, restoration procedures, automatic line switching, emergency power, etc. Coax cable systems most economically meet present demands for additional circuits, where there is the need for facilities that will be capable in the next decade with communication systems now under development, and where maximum continuity is required. Everyday hazards must also be taken into account. The two most common hazards are lightning and construction contractors. Lightning can travel along cables, heating and vaporizing moisture and other substances. The resulting pressure sometimes damage the tubes which make up the cable. Contractors are apt to digging into lines, not knowing their exact location. Efforts are made to make them aware of cable routes. Amplifying stations, unmanned, are found at intervals of 1 to 4 miles. Depending upon the system, the station boosts and signal levels of the carrier to ensure high-quality service. The policy of avoiding the larger cities and other possible nuclear targets creates basic protection because the caution systems must serve the target areas. The communication systems must serve the target areas. This service is achieved by locating junction points outside the danger areas and running branch cables to them. Corona, California, for instance, is a junction point for Los Angeles. It is a town of 15,000, 50 miles to the southeast. Hillsborough, Missouri, a settlement of 500 people, 30 miles southwest of St. Louis, serves as a junction point for the metropolitan area. Nuclear detonations within a major city, therefore, with distribution of communications for the city is by virtue of direct hits affecting its branch cables, would affect only the city involved by the attack and not the network itself. The same pattern is followed throughout the country in case a number of metropolitan areas are subject to attack. Here again, local branches only would normally be exposed to serious damage in this way. In the event of nuclear attack, the possibility of a network coax cable and communications centers being disabled by nuclear weapon blast effects is exceedingly small. The high blast resistance means that any component would survive anything short of a direct hit. Thus, it is highly probable that in a nuclear attack upon the United States, the hardened network of telephone communications would remain intact and would continue to serve the country as a whole without interruption through the crisis period. Many other industrial organizations have also taken deliberate steps to protect their organizations and to bring about survival and recovery of their functions in a nuclear war. Many of them have invested heavily in shelter facilities, remote locations, emergency operations, and disaster recovery. Many of them have extensive plans to do even more and more to foil an enemy effort to crush our machinery of production. But AT&T, with vital support from Western Electric and other partners in the effort, has, with its underground coax systems, achieved a dramatic breakthrough in demonstrating what can be accomplished in the field of industrial survival. The growing network of protected coax cables and their hardened communication centers now reach across the nation, from the Atlantic to the Pacific, and from the Great Lakes to the Gulf of Mexico, through the thousands of additional circuits provided to the booming economy. It takes care of the substantial year-to-year increases in telephone traffic. The first requirement for the network is that it be as practical and valuable in time of peace as it will be in time of war. It is indeed a true dual-purpose project. The Essence of Security, Reflections in Office, by Arthur A. Broyles. The Essence of Security, Reflections in Office by Robert S. McNamara, Harper and Row, for $4.95. This book is Robert McNamara's case for his performance in office as United States Secretary of Defense. This alone makes it worth reading. In addition, its style is readable and concise, and it lacks the boring repetition that characterizes so many books of this type. McNamara states clearly the basic assumptions on which foreign policy decisions of the Kennedy-Johnson era have been founded. This nation, he writes, made the decision at the end of World War II to base its own security on the principle of collective defense. This was done with the hope of helping to create, in keeping with the principles of the United Nations Charter, a world in which even the smallest state could look forward to an independent existence. The reason for this decision is that without dependable friends or allies, we surely would have to maintain a large military establishment than at present. We also would have to reorient our industry and commerce to achieve a maximum degree of economic self-sufficiency. With a lower standard of living for our people and considerably less economic freedom, in time we could find ourselves literally isolated. A fortress America, still relatively prosperous, but surrounded by a sea of struggling, envious, and unfriendly nations. A situation hardly likely to strengthen our own state of peace and security. As to China and the Soviet Union, he feels that realism bids us both to seek understanding with them and to recognize that, in some areas at least, they remain fundamentally hostile to us despite their own differences. He does look, however, to improve in Soviet-U.S. relations once Hanoi's aggression in Southeast Asia is terminated. His discussion of China and her conflict with the Soviet Union is most interesting. Although we have found the Vietnam War to be discouraging, McNamara points to many encouraging signs of regional cooperation in Southeast Asia. He summarizes the Chinese objectives as being to establish herself as a major political influence in the area exploiting Pakistan's and India's difference to her own advantage, preventing or delaying development of a strong India, and minimizing the United States and Soviet influence. As for the Middle East, he emphasizes that in recent years the Soviet Union has sent a considerable portion of its total economic and military aid to that region. Her shipments of arms to North Africa threaten to seriously disturb the balance of power between the states in that area. McNamara continues to press for a strong NATO, saying, certainly the Soviet Union shows no sign of intending to reduce its own defense expenditures. On the contrary, it has increased them. The cost to the United States of losing Europe to Russians is pointed up by the statement. The 6 common market nations plus the United Kingdom have by themselves a total population, military manpower pool, and gross national product considerably larger than the Soviet Union. McNamara is also optimistic about the possibility of NATO stopping a Russia conventional attack on Western Europe. On the whole, he says, NATO already has the manpower and its active forces to deal with opposing combat units, even when East European divisions are counted. Its deficiency lies in the need for improvement and deployment of NATO's forces in Germany, and the fact that not all the supposedly combat-ready units are adequately trained, equipped, and supplied. A discussion in some detail is given as the saying made by the Defense Department during McNamara's term in office, principally through the introduction of improved managerial methods and the use of operations research. It is disappointing, however, that he omits any mention of the TFX controversy. His explanation of the Navy's rejection of its version of this fighter plane would have been interesting. A section of the book is devoted to a description of the way the Defense Department has used its vast expenditures and its influence over men in the armed forces to promote social change within the United States. Examples are found in integration of races in the armed forces and the attaching conditions to contracts let to manufacturers. Training programs have also led to development of new educational techniques. Perhaps the most interesting thing about the book is the opportunity it affords us to understand McNamara's precisely because of his certainty that the 4 prominent scientists who have served with distinction as the science advisors to President Eisenhower, Kennedy, and Johnson, and the 3 outstanding men who have served as directors of research and engineering to 3 secretaries of defense, have unanimously recommended against the deployment of an ABM system. Now these scientists were competent to discuss technical questions about the ABM, but they were not experts on the question of what Russians would do in response to our action. In fact, it is possible that scientists are below average at considering such questions because their primary concern with scientific matters. Thus, they lack the breadth of understanding required to predict the behavior of nations. McNamara has revealed the danger that our government may be influenced in some critical decision by men appointed to their office rather than elected, and in addition drawn from a group whose views can easily be a strong variance with those of the American people. Also, the argument against deploying the ABM system seems as weak as the argument why build tanks when the enemy can build anti-tank guns and rockets much more cheaply. In addition, there remains the question of attack from other countries that may require nuclear weapons, such as Red China. who might assume that their missiles launched from submarines would be mistaken for those from the Soviet Union. One vital question in our nuclear attack capability is our nuclear attack capability relative to that of the Soviet Union. McNamara's statement on this point is but using the realistic measurement of the number of warheads which could be delivered with accuracy and effectiveness and on appropriate targets. The United States currently possesses a superiority over the Soviet Union of at least 3 or 4 to 1. However, several other sources have indicated that the Russians are advancing so rapidly in this field that they will soon pass us. See Edward Teller's Comments, Survive Volume 1, Number 2, page 1. Although McNamara discounts the number of delivery vehicles as a measure, it is disconcerting to see newspaper reports with estimates of the British Institute for Strategic Studies that in 1965 the United States had 4 times as many ICBMs as the Russians, but in 1967 it had only 2.5 times as many. And at present supplies of land-based ICBMs are approximately equal. However, present land plus fleet ICBM totals attribute about 1,700 to us and 1,100 to the Russians. The book then leaves the impression of a supremely self-confident man who undoubtedly improved the operation of the Defense Department erroneously, who made great efforts to economize and to improve the efficiency of conventional armed forces and our nuclear attack forces, but who, because he refuses to take account of all eventualities and the responsibility that he might have made some mistakes, may have left his country so weak in nuclear survival capacity that it will someday be blackmailed into position of a second-rate power or destroyed as a nation. CAP, a civil defense bonanza prepared by the Information Office, National Headquarters Civil Air Patrol. The Civil Air Patrol, or CAP, a 28-year-old organization of aviation-oriented men, women, and youth, 85,000 strong, is a uniquely important element in the civil defense plans of America. As a volunteer civilian auxiliary of the United States Air Force, CAP is closely linked to the Air Force operations and conducts aerial search and rescue operations under the direct supervision of the Air Force Aerospace Rescue and Recovery Service. CAP also assists in the Air Force in disaster relief operations and natural disasters such as floods, hurricanes, tornadoes, and earthquakes. CAP presents a constantly ready and sizable nucleus of trained personnel and specialized equipment which can be readily integrated into civil defense planning of all 50 states in the event of a national emergency. CAP Organization and Development. A CAP wing in each state is specifically tailored to participation in civil defense, through a series of officially approved written agreements with the civil defense directions in all 50 states. CAP is prepared to place its personnel and physical resources at the disposal of Civil Air Defense headquarters in the individual states, either as complete units, statewide, or in small components at locations where civil defense action is required. These CAP-CD agreements are so oriented that in the event of either a national emergency or regional state disaster necessitating civil defense measures, CAP can respond effectively to civil defense requirements. Services CAP's offers include radiological monitoring. CAP has special teams in hundreds of units throughout the nation which are trained to detect and to measure radiological contamination. Courier and messenger service. CAP's sizable inventory of small aircraft is available to supplement aerial resources of civil defense in the essential task of moving civil defense staff and command personnel in disaster areas. Aerial surveillance. CAP airmen trained in aerial observation can monitor surface traffic conditions and help civil defense establish orderly and unimpeded flow of traffic. Airlift of emergency personnel and supplies. CAP Airfield can make a significant contribution to civil defense activities by air transport of emergency supplies and critical personnel such as doctors, nurses, first aid supplies, etc. Aerial reconnaissance. CAP aircraft and personnel can accomplish photographic flights, enabling civil defense to concentrate their resources where needed. Radio communications. CAP maintains and operates a network of more than 21,000 radio stations with the capability of providing civil defense valuable communications nationwide, regional, or local. Total resources for CAP include 3,430 member-owned aircraft and 824 corporation-owned aircraft, 4,500 surface vehicles like trucks, sedans, jeeps, ambulances, and vans, and 21,525 fixed, mobile, and air mobile radio stations. This sizable force is an in existence reality with a capacity to boost in significant measures the overall civil defense mission national survival. So Be It by John F. Gear. Sorry if I butchered that. It is already clear that the new Nixon administration will be free of certain philosophies and prejudices which have prevented the development of a realistic civil defense program in the United States. The present administration has been satisfied with party parity in strategic weapons and the mutual hostage situation of our people along with the Soviets. It has sought to reduce the risk of nuclear war through negotiations and by setting an example of restraint in the arms race. Top-level endorsement of national security programs, including civil defense, has been considered bad politics, both domestic and foreign. Strategic defense funds declined from 13% of the federal budget to 4.5% during the Kennedy-Johnson years. Decision by cost effectiveness further frustrated strengthening of defense. The fiction of technological plateau was raised to justify policies capable with parity and cost effectiveness. Warnings of rapid Soviet acceleration in quantity, quality, and variety of strategic weapons systems, both offensive and defensive, were ignored when they came from Congress, the Joint Chiefs, and other reliable sources. It is not surprising that civil defense has also been neglected. Established goals, programs, and support have been abandoned. Commitments to states and local governments, industry, and the public are no longer honored. There has been no serious consideration of protection for people in potential target cities from blast and heat effects of nuclear weapons. Consider these comments on our current civil defense program. Congressional Committee Chairman. The Executive Department has never given Congress what I would consider to be an effective civil defense program. Civil Defense Forum Letter to President Johnson. The United States is not doing what it should to reduce our vulnerability to nuclear attack. Former Assistant Secretary of Defense. The federal government's participation in civil defense over the years has not been consistent and has not been fully responsible. European civil defense official. You, the United States, have failed to give us this civil defense leadership. You are dreaming of angels in a world of devils. There is every indication that strategic defense will not be neglected by the Nixon administration. Mr. Nixon has been advised by military experts, not starry-eyed advocates of unilateral disarmament. His position papers advocate negotiating always from strength and never from weakness, and resolve not to be left behind by the Soviets in their race toward superiority in nuclear striking power and ballistic missile defense. However, neither Mr. Nixon's position papers nor the strategic defense studies on which the position papers were largely based consider the role of passive defense. It seems to me that there are two explanations as to why this component of strategic defense has been overlooked by the defense advisors to Mr. Nixon. First, it is a matter of professional tradition and pride that our military men have always been able to defend the homeland and protect civilians from foreign enemies. In strategic defense, this tradition naturally relies on offensive deterrent capacity and on active military defenses. Second, research and risk studies emphasize weapon systems such as anti-ballistic missiles. The known art of hard shelter for people receives very little attention, and it is commonly assumed that civilian organization officials and the public are unable to effectively man and utilize passive defense systems. The task facing responsible advocates of civil defense is to persuade the new administration to make a complete new study of the subject. If this is done thoroughly and objectively, and the result considered by top policymakers, there is every reason to believe that the Nixon administration will assign to civil defense a role commensurate with its potential contribution to the security of our country. I believe that civil defense, in conjunction with active defenses, could assure that the nation and the great majority of our people would survive any attack. Such a posture of assured survival, added to the credible assured destruction capability, would give us a fully reliable deterrent against surprise attack and nuclear blackmail. If so, civil defense will emerge as a vital element of the strategic defense of the United States. Warning time requirements for blast shelters. An incisive and incisive look into the question of how many people could really get to urban blast shelters in time if they were readily available and if warning were effective. It has been evident for a long time that a large fraction of the nation's population is to survive a sizable nuclear attack. Blast shelters must be provided in some areas. The most serious blast shelters must be provided in some areas. The most serious objection as to the feasibility of such blast protection has been the briefness of the time between initial warning and the nuclear explosion which people must reach blast shelters. For this reason, the Civil Defense Research Project of the Oak Ridge National Laboratories is conducting an investigation to determine the length of time people were required to reach the protected areas and to determine what measures can be taken to reduce this time. A preliminary report by Dr. Henry F. Gados of some results obtained appears in the project's annual progress report from March 1966 to March 1967 and is summarized here. The first and most obvious requirement of a blast shelter system to minimize the entry time is to have shelter entrances as near as possible to the people. The tunnel grid system satisfies this requirement most admirably. For a description of such a system proposed for Tucson, Arizona, see Survive, Volume 1, Number 3, page 1. This type of blast shelter is the one considered by the Oak Ridge Group. Any study of this kind is subject to a large number of variables and many uncertainties. For example, the effectiveness of blast shelters may be appreciably greater than indicated in this report because of two distinct possibilities, both extremely difficult to evaluate. First, the initial strike may come during a period of international tension or provocation so severe that many people occupy shelters for major portions of each day. Second, all areas not hit by the initial strike will be so vividly warned by it that the area's blast shelters will be almost fully occupied for subsequent strikes. For other examples, it makes a difference whether the area served contains principally 1 or 2 story homes, or tall buildings consisting of 10 or more stories. The time required to evacuate tall buildings can become a major contribution to the time required to reach shelters. The best that can be done is to select a set of sample cases and to determine the required time for those samples under a clearly stated set of assumptions. One of the samples chosen by the Oak Ridge Group is a 30 square mile area of downtown of northwest Detroit. This is primarily a residential area. Some results for this sample are given in Dr. Gatos's report. The tunnel grid considered for this Detroit area placed a shelter entrance within 4 or 5 blocks every residence. However, one of the principal purposes of the study was to determine how much advantage resulted from spacing entrances so that they serve equal areas and provide the shortest walk for others rather than spacing them at equal intervals along the tunnel. A second major objective was to determine the adequacy of a 15-minute warning time. This figure has often been given as the warning provided by a radar system against an ICBM attack from the Soviet Union. The third objective was to compare the effectiveness of a siren warning system with that of a radio-actuated defense device placed within each home and in public buildings. To shed light on this problem, estimates were made of the time required to alert 95% of the population in the area study of various levels of loudness of the siren noise, measured in decibels. An optimistic estimate and pessimistic estimate were made, and the differences between them are shown in Table 1. Alert time in this table is the time required after the warning is sounded and before people decide to go to shelters. It increases with lower siren noise levels because fewer people hear and recognize the warning. A study of the Detroit area showed that most of it would have less than 80 decibels from existing sirens. On the other hand, it was estimated that most of the people would be alerted in 1 minute's time by the radio alert system. This conclusion was drawn from a study showing that 90% of the population responded to a telephone ring within 30 seconds. USSR. The following article appeared in Krasnaya Zvezda, the Journal of Soviet Army. It was translated from Russian into English, French, and German by the International Civil Defense Organization. The following is taken from the International Civil Defense Bulletin published in Geneva, Switzerland. In the USSR, as in many other countries, special attention is given to evacuation and dispersal as a means of civil defense. Evacuating and dispersing city dwellers to less exposed areas is considered one of the most efficient means of protection against weapons of mass destruction. It is generally agreed that evacuation and dispersal under conditions which prevail today require a detailed and precise organization of personnel and materials. The population, for its part, must strictly follow the given instructions at the moment of evacuation and dispersal. Citizens must be well informed on preparations for and the implementation of evacuation procedures, as well as on their expected conduct. Industries, institutions, and organizations will receive instructions on where, how, and what transport means, and from which assembly areas their personnel will be evacuated. This information will then go to all those who are to be evacuated. Thus, people in the cities will be informed in detail on everything connected with their evacuation. For this purpose, a specially selected information staff will occupy one or more buildings. In the larger cities where workers and employers live scattered about town, it is more difficult to keep the public informed. In such cases, the local radio, television, and telephone, as well as posters, will be used. In the USSR, the starting point for all evacuation and dispersal organizations is the place of employment. Only retired people are evacuated from their homes. Hence, evacuation and dispersal measures are carried out from assembly areas that tie in with employment locations. All personnel and all means of transportation are gathered together in these assembly areas. Routes to be followed outside towns are determined in advance. Assembly areas for retired persons living alone are established by the various housing officials. Every person to be evacuated knows the address and number of his assembly area beforehand. Organizational plans include provisions to prevent assembly areas being overrun by too many evacuees at one time, as this could completely paralyze city traffic. Therefore, each industry, workshop, or institution has a predetermined time for evacuation. All those to be evacuated receive a special identification card. Each card has 3 parts: the original card, a copy, and a control slip. It contains surname and first name of the person to be evacuated, the father's first name, date and place of birth, home address, number and address of assembly area, and the reception center. The special card, together with the regular identity card, are the official documents of the person to be evacuated and guarantee him his rights in case of emergency. The control slip is picked up at the assembly area. Upon travel thereat, for control purposes, and the evacuated person turns in the copy of their card when he arrives at the reception center. When informed that an evacuation operation has been launched, the person concerned gathers and packs his personal belongings, clothes and food, up to a limit of 110 pounds. He is advised to take his identity card, money, his military papers, his birth certificate, and other documents, as well as his evacuation card. He must check beforehand the time he needs to get prepared and to reach the assembly area so as to get there on time. He's also cautioned not to arrive too early. Example, before the time indicated. Before leaving home, the evacuee must turn off the electricity and gas and must lock doors and windows. Finally, he must inform the caretaker of his building of his departure and instruct him to keep an eye on his apartment. When he arrives at the assembly area, the evacuee will register and hand in his control slip. He then receives his transportation ticket. Then, following instructions and guidance of the evacuation committee and the supervisors, the evacuee takes his allotted seat in the train or other transport vehicle. No getting off or changing of places or cars is allowed after boarding. At the reception center, all evacuees turn in copies of their evacuation cards and registered with the lodging committee receive lodging papers and are accompanied to their living quarters. Then the evacuee receives tickets with which they can buy or receive through the local markets the food and other necessities they will need. In order to avoid confusion in the lodging of evacuees, changing in lodging plans from one locality to another are prohibited. In the reception center, immediate arrangements are made for protection against fallout radiation. Empty cellars, underground silos, and other spaces are adopted to this use. Simple trench-type shelters are dug. The evacuated city dwellers participate in activity in this work. Medical care at the reception center is supplied by local hospitals and first aid stations, supplemented by medical and auxiliary personnel recruited from among evacuated persons. Medical care is also provided at assembly areas and intermediary stations. Furthermore, each evacuation train or convoy has its own first aid section, organized with the help of evacuated physicians and nurses. Local authorities take steps to assign jobs to everyone capable of working. Those trained in the political field will maintain order and discipline during evacuation and dispersal. With this in mind, authorities stress the need for and the significance of such evacuation measures during peacetime. During evacuation, the population is constantly kept informed of the situation and special measures that must be taken. Interlaken. Following are conducted notes of the proceeding of the Interlaken Switzerland Radiation Conference, held under the auspices of the Fachzwer Band für Strahlenschutz, Technical Union of Radiation Protection. It has long been known that radioactive elements and fallout could be assimilated by plants and then become part of food consumed by humans. The danger from the element strontium-90 is recognized since it can replace calcium in cow's milk and from there be absorbed into human bones, particularly those of growing children. From this location, it can fire its radiation into human tissue at close range. However, it is not too difficult to control this problem by temporarily eliminating food such as milk from human diets and providing calcium from a purified source. It is also relatively easy to eliminate strontium-40 from milk itself. It was clear at the conference that much more concern centered around another element, radioactive iodine, which is also contained in fallout. Of particular interest was the effect of this element on the thyroid glands of small children living in the Marshall Islands at the time of the Pacific Bravo nuclear test in 1954. An unexpected shift of winds caused an excessive amount of fallout to come down in the area. Some 10 to 14 years after the explosion, it was discovered that these children had received a thyroid radiation dose of 700 to 1,400 rads, compared to about 175 rads that they had received from the whole body radiation originating from fallout particles outside their bodies. Thus, the ratio of thyroid to total body radiation was between 4-to-1 and 8-to-1. It was recommended that further animal research be carried out to determine the maximum safe thyroid dosage for small children. It would be particularly desirable, it was felt, if therapeutic drugs could be found to counteract radioiodine disposition in thyroid glands. The availability of radiation monitoring instruments was also discussed. It was pointed out that the people who are concerned with radiological defense and war emergencies have a different language from those who deal with radiation safety in civilian life. Enough nuclear bomb testing has been done so that the radiological monitoring and decontamination specialists know exactly what to do. In peacetime nuclear catastrophes, this experience is lacking. This latter case differs from the bomb explosions, and that analysis of what radioactive elements are present is necessary. Actually, 3 different classes of emergencies are involved: nuclear warfare, accidents involving nuclear weapons, and civilian nuclear accidents with nuclear piles of other sources of radioactivity. There seemed to be no problem in the construction of proper radiological monitoring equipment. For instruments for monitoring fallout distribution in the nuclear explosion, most people believe an upper limit to their range should be at least 100 radigens per hour, although some believe 10 radigens per hour is sufficient. For special accidents, such as those with nuclear reactors, instruments may be needed capable of reading up to 2,000 radigens per hour. The medical doctors at the conference, as well as the majority of the other participants, believe that the emergency civilians should carry dosimeters registering up to several thousand radigens to determine the total whole body radiation that they have received. Although some of the conclusions reached at the conference will be the subject to change as additional information becomes available, the consensus was that the conference was of great value in summarizing current knowledge and in pointing up areas where additional research is needed.